Okay, quick question. You're asking yourself, how do I determine if a polynomial function is even or odd? Wait, follow-up question, what does that even mean? Great questions. Okay, well, to help answer those questions, let's talk about symmetry. What is symmetry? Well, we've talked about symmetry before, right? We've talked about that parabolas or quadratic functions have an axis of symmetry. Remember, symmetry means that it, if in this case on axis, we would fold over that axis and it would mirror itself on one side or the other. So let's try to identify symmetry. So I'm just rambling now. Take a minute, pause the video, and identify for each one of these graphs, does it have y-axis symmetry, origin symmetry, or neither? Neither would be, it doesn't have either type of symmetry. So pause the video, see if you can identify that, unpause when you're ready to check. Okay, so the first one here, this has y-axis symmetry. And I can see that because, again, if I think about the y-axis here as something that I would fold the graph over, so if I pick any point on this graph, so if I pick this point xy, and I fold it over the y-axis, it should land on another point on the graph that would be the exact same point with the opposite x value, but the same y value. So this is y-axis symmetry. So again, every single point on this graph has a corresponding point on the other side of the y-axis that has the exact same y-coordinate, but an opposite x-coordinate. The middle one here, this is origin symmetry. Now, origin symmetry is a little bit more difficult maybe to visualize because it's not a flip, right, or a reflection over a line. It's a reflection over a point. What does that mean? Well, another way that we talk about origin symmetry is sometimes we call it rotational symmetry. And so if I picture the origin as like a pivot point, right? If I take any point on the graph and I call that point xy, if I rotate that point around the origin 180 degrees, I should end up at some point negative x, negative y, or opposite of x, opposite of y, because I don't have to have a positive value, right? If I take this point right here, which looks like it's the point -1, +2, then I can see I have the point +2, or I'm sorry, +1, -2, right? And so pick this point, I have a matching point rotated around the origin that is the opposite x and opposite y of that point. So that is what we call origin symmetry. This one here, it doesn't have symmetry about the y-axis or the origin. And remember, we're specifically talking about the y-axis and the origin, right? So, for instance, if I took a parabola only has symmetry about the y-axis if the vertex of the parabola is on the y-axis. If the vertex of the parabola is somewhere else, the parabola itself still has symmetry because it has an axis of symmetry, but it doesn't have y-axis symmetry or origin symmetry. Okay, great. Well, now you're asking yourself, wait, the beginning of this class, you weren't talking about symmetry, you were talking about even and odd. Glad you brought that up. If a function has y-axis symmetry, it is what we call an even function. If a function has origin symmetry or symmetry about the origin or rotational symmetry, that is what we call an odd function. We can determine this analytically by doing some algebra, using the same thing that I just talked about here, where for even or y-axis, for every xy, I have an opposite of xy point, and for origin, for every xy, I have an opposite of x, opposite of y point. However, the easiest thing to do is just look at the graph. So that's how we're going to do it here. So what I want you to do is determine if each of the following functions is even, odd, or neither. Use your calculator or Desmos to help you out with this. Pause the video, graph them, unpause when you're ready to discuss. All right, so hopefully you came up with f of x is odd, g of x is even, h of x is neither. Let's talk about them, or look at that. So I use Desmos for this just because I think it's a little nicer visually and a little bit quicker and easier to type in on a computer. But you can also use your calculator, and you'll want to know how to use your calculator for like a standardized test. So I can see here is my f of x function. If I take, well, that's not a great point. So like if I take this point here, negative 2, 0, I can see I have a point 2, 0 that I would rotate those here and here. So that's a better visualization for that rotation. So notice the xy coordinate here and the xy coordinate here is the exact same thing, but opposite x and opposite y value. So if I rotate that around the origin 180 degrees, I end up at this location. This was a bad example here at the negative 2, 0 and the 2, 0, because that would also appear that it's symmetrical about the y-axis. So ignore that and use these 2 points that I just talked about. And that is our rotational symmetry. Again, if you just visualize rotating the entire graph, if you could see me, you would see a gesture that I just made showing rotation, but you can't see me. So this one again, origin or rotational symmetry, so it is an odd function. G of x is even, and I can see that here again if I pick any point this is at 1.34 comma 4.02 and this here is at negative 1.34 comma 4.02. So again, it's showing that the x coordinate became opposite, the y coordinate stayed the same. This is a little bit easier just to visualize anyway, that I can see it looks symmetrical about the y-axis. And then h of x was neither. To be fair, if this plus 2 wasn't here, it would have had origin symmetry, but because that moved it up 2, now if I rotate about the origin, I don't end up with that symmetry that we've talked about, right? So like if I pick this point here, and then I pick this point here that would match it, those don't go together, right? That the x values are opposite, but the y values are not. So that one's neither. Okay. So just summing that up, even functions are symmetrical about the y-axis, odd functions are symmetrical about the origin. We sometimes call that, or we can also call that rotational symmetry, but functions don't have to have either type of symmetry, so they do not have to be even nor odd. Nice work.